So I'm Kat Young. I work for H2M as a wastewater engineering practice leader. And today's panel will be focused on municipalities that are facing sewer capacity constraints. We'll talk about types of tools, techniques, and strategies that can be pursued and utilized to better understand where the constraints or bottlenecks are. And as well to tools for more accurate data to really understand possibly how you might be able to remedy or remediate capacity challenges, and especially in light of the funding at the state level for brownfield redevelopment, affordable housing expansions, improved access to, is it working? I'm too far away, so, oh my goodness, okay. Anyway, we're seeing a lot of things at the state level, which is providing funding and loans that ultimately are driving increase in industrial, commercial activities, population growth, et cetera. So much of the infrastructure in Connecticut is starting to age. So you've got that, as well as just having that demand and increase in capacity needs. So we thought this was definitely a relevant topic for many of the municipalities here. And this panel group was spearheaded by one of the CTWIA committees, the Small Community and Collection Systems Committee, of which Norb Church, who's one of the panelists, and myself are co-chairs. So let me get going to introducing our panelists. Just wave your hand. There's a couple of people I've only met via email. So we have Ted Donahue, who is superintendent for Litchfield Water Pollution Control Authority. We've got Travis Savy, who is the COO for Savy and Sons. Ben Rukavina, key account manager for ADS Environmental Services. Norb Church, who is Esquire and founder of Church and Church. We also have Martin Heft, Undersecretary of the Office of Policy and Management for the state of Connecticut. Joseph Hausman, a professional engineer with Wright Pierce as lead project engineer. James Veerling, also a professional engineer who is a discipline engineer and associate with H2M. And then lastly, but not least, Eric Hess, who is sales manager with FR Mahoney and Associates. All right, just kind of the flow. We've got some key definitions and concepts. I have a feeling most everybody in the room could probably actually stand up and go through some of the slides with just as much efficacy as our panelists, but just want to make sure we're all on the same page. Some people call certain things different things, and maybe just based on the experiences, some people may have less experience with utilizing flow metering, addressing I&I, or even involvement with hydraulic models. So we'll just go through some of those basics. I'll kick us off because people can be shy. So we've got some questions and topics to kind of get us going. And certainly we want questions, as many and as often as possible. So feel free to jump in after we get through a couple initial questions and some of the slides. Okay, and panelists, because you guys cannot see the PowerPoint presentation all that well, feel free to stand up and come on over to your slides. So Travis, not to put you on the spot, but a little I&I, if you please.
You want me to come over here?
You.
Appreciate it. Hi, everybody. Travis here with Savy and Sons. Can everybody hear me okay? Excellent. So let's start with, how many of you all know what I&I is? Wow, everybody's very smart. That's excellent. Excellent. So I&I, inflow and infiltration. This can come up in a lot of places as we're here talking about. It can be in sewer systems. It can start at the manholes and riser joints, lift joints, pipe penetrations, all within the sewer manholes. This can be through the pipes here shown. It could be from the lateral service connections coming from buildings, houses at the connection where the lateral meets the main lines. It can also be coming from the building or the house. We see a lot, could have leader drains from the gutter downspouts, sump pumps, things like that tied in. So there's a whole underground avenue where I&I could be coming from, which is essentially stormwater that enters the sewer system through the rain leaders, basement sump pumps, et cetera, foundations, drains. This can burden on the collection systems and the wastewater treatment facilities and definitely suck up a lot of funds and most of the times out of sight, out of mind.
Next, I want to ask Ben to come up just briefly and talk a little bit about flow monitoring.
Hello, everyone. So nice to be here. I'm sure most of you are also familiar with flow monitoring, but I just wanted to touch on the basics for those of you who may not be familiar. So, when talking about capacity, flow monitoring, and kind of understanding what's actually going on in the system is really important. So, there's a number of ways of doing this, but basically, oftentimes you have kind of a data logger that's transmitting data, right? And you're actually installing a sensor into the collection system. So, as you can see here, we have kind of a meter at the top of the manhole, and then an area velocity sensor down in the pipe. And that's a typical setup. These are kind of devices that can be deployed all throughout the system. They're battery powered, and oftentimes are communicating to some kind of wireless or cloud platform, so you can view that data in real time or near real time. I have a few sensor types, and then just also overall typical objectives that we have when we're doing flow monitoring. But again, kind of understanding capacity, in this conversation, that's a really important first step, is kind of understanding what's actually going on in the system. Is there another one?
Yeah, there is.
Oh, yeah. And, just have a kind of screenshot of some typical flow data. For those of you who maybe have not seen it, you'll kind of see this increase in flow over the day, and it's typically a diurnal pattern. So in the morning, folks are using a lot of water, and then kind of that peters off as people go to work. And then when they're returning and kind of maybe showering or cooking, you see another flow. So kind of looking at those peak flows in compared to the average flows, again, is an important step in understanding what's going on in the system. So.
All right, now we'll touch a little bit on hydraulic modeling, and Joseph will come up. Thanks.
All right, so I'm going to steal a little bit from what was before. How many of our operators or towns around here have and run a hydraulic model currently? Fewer hands than people who are aware of II. So as we start talking about protecting capacity, we've got the flow monitoring component, but also it's the understanding, well, how much capacity do you have in your sewer system? That's where hydraulic modeling comes in. And I always talk about hydraulic modeling in two parts. There's the flow data that we talked about, but then there's what I always think of as the skeleton, the pipe network. So the biggest thing there is to create the pipe network, have the infrastructure, the knowledge of the infrastructure. So the people who have GIS systems, pretty much if you have that information, on the left side here, the pipe network info, really that's what the information you need to collect on the structure to know to set it up. The biggest parts are pipe size, pipe slope, obviously locations, and pipe material. That at least is the first bit that you can start with a hydraulic model. The rest of the information beyond that helps you with added levels of complexities, which we'll get into, I bet, probably later. And then obviously, as we talked about on the flow side, those are the sources of flows, whether you actually have flow metering data, can you estimate based on lot counts, types of uses, and things like that. But different ways to create these two, and then of course, putting these things together. How much capacity do your pipes have? How much flow is actually in your system? The comparison of those is how you start to get to the answers of, do I have capacity or not? Especially as these questions of growth start to come up.
And this will be for Travis from Saving Sons. So I&I Strategies, feel free to answer from the, over there, and just talk a little bit about some of the reduction approaches in regards to I&I.
Me?
Yes.
Oh, I can't really see the slide over there. Yeah. So is this too loud? We're good? All right, cool. Yeah, absolutely. So reduction strategies, as I briefly went over prior, starting at the manholes, right, kind of the central point there, the riser joints, the lift holes, all those things, the pipe penetrations where they're coming in through the manholes. Those are a lot of areas of reduction strategies, just simply popping a manhole cover and going in there and looking, do you have any water pouring in? From a show of hands in the room, does anybody know if, where you work or anything, is anybody doing that, checking any I&I? Yeah, a little bit. Yeah, that's good. I mean, that's where it starts. If you don't know, you can't fix it. And the main thing we see in the industry being a service provider is out of sight, out of mind. Driving down the road, you see a pothole, whatever, let's dig it up, fix the pothole. Well, why is there a pothole? Mostly because the underground infrastructure is failing. A lot of times it could be I&I, and it's taking all the gravel and fine sediment and silt with it. You have to fix the source of the problem, or you're just going to be putting Band-Aids over on the top of the roads. But the thing is, that's what everybody sees. Millions and millions of people drive over the roads, complain about the potholes. The money goes to there to put lipstick on a road. That being said, you need to get underground and fix the source of the problem. The other big thing is going in there and cameraing the pipes. A lot of times, we camera brand new pipes, brand new installs, and we go in there and like, oh, they don't need to be cameraed, they're good. Okay, sounds good. You guys had an inspector, checked it out when you backfilled it and everything, and then we go in and camera it, and there's a pinch joint or there's a nick in it, and there's water pouring into a brand new sewer system. And we'll get into later some of the cost analysis of that. A big thing we see is you're already spending the money. You're actually spending a lot more money in treating clean groundwater I&I in your sewer system that you would spend less money if you just stopped the I&I. I like to get interaction, make sure I'm not putting everybody to sleep. Does anybody have any questions? Actual real scenarios or anything like that? Go ahead.
Yeah, in Fairfield, we just had National come in and line a ton of our pipes, and John and I, we've seen a change in our numbers daily. So it's truly important to the infrastructure of our plant in particular. But yeah, it should be done, it must be done, it must be blocked, it must be recorded, and it does make an impact.
Yeah, that's great. I appreciate you speaking up and sharing. So he just had in Fairfield a bunch of their pipes lined, cured in place pipelining, CIPP, to seal out a bunch of I&I. You can also do pipe grouting, top hats, lateral service connection, seals, a lot of things like that to stop that I&I. And he was able to track it on his flow at the plant, and you can literally see your savings because everybody knows what they're paying to treat their wastewater. Well, you can now do the math, and I'll get into that on one of my future slides, but you can see the money you're saving. So it's a very rewarding investment into your underground infrastructure that should hold for many, many years to come. So appreciate you sharing that. Anybody else? Go ahead.
Can you just speak briefly to people who may not know, like obviously lining is significantly cheaper than dig and replace. Can you just kind of speak to what that actually looks like in terms of savings?
Yeah, absolutely. So just to be sure I understood correctly, speak to the difference of traditional dig and replace excavation compared to CIPP cured in place pipelining.
Yeah, the value you're getting with lining essentially.
Yeah, absolutely. That's a great question. So again, being a service provider, we're very familiar with it. You have a pipe that's destroyed, cracked, leaking, things like that. You can't line every pipe. About 85% of pipes you can line, some of them with bellies and collapses, things like that, you may still have to dig and replace. But the ones that are lineable, people that are, NASCO, ITCP, PACP, MACP trained to be able to make that decision with an inspector reviewing all that information as well, when you can line a pipe, it is much faster, nearly non-invasive at all, can be very cost effective because you don't have all the landscaping and excavation and everything that goes along with it. It could be multiple times faster, therefore saving a lot of money to essentially have a brand new pipe within an existing pipe versus digging it up and installing a new pipe traditionally. Is that good?
Yeah, basically, yeah. Thank you.
Okay, yeah, absolutely. I want to make sure I answered what you were looking for there. Yeah, absolutely. Thank you. Go ahead.
Out of all the projects that you do, what's the most common location where you see infiltration?
Out of all the projects we do, because we do everything underground, it's most commonly manhole infiltration. It's at where the frame, the steel frame, meets the top of the manhole structure. It's at the lift holes, which the lift holes are just holes in the precast concrete where they pick it with the machines when they set it. And normally they may not do anything, or they might just put a little rubber plug in there, which we're human beings and don't always do a good job. And those can leak, or the riser joints where they put together the pieces. They're supposed to be conceal butyl in there to seal them, and a lot of times where it meets, it'll leak right in there, and it's leaking in there. And then also the pipe joints where the pipes come through the manhole. So we're a big advocate of periodic reoccurring inspections, which we do a lot, because even with a brand new install, you can install it, okay, looks good, and the contractor may have dewatered and everything. This is talking about new. They may have dewatered it while they were doing all the excavation and everything to get rid of the groundwater, right? And mind you, all the piping is laid in stone bedding sand, which is a great avenue for groundwater to follow those pipes right to the manhole. So they backfill this thing, it's dry, not leaking, it's inspected, passed, everybody see you later, sayonara. Well, after time, just like a frack in a well, this water's tracking all the stone and the sand coming down the pipe, and it's gonna follow the path of least resistance and find its way in somewhere, which is typically the pipe penetration, which when newly installed may have not been leaking, but after time and hydraulic pressure and water tables, difference in seasons and everything, it finds its way in. But everybody's like, no, it's good, we checked it. Well, times change. You got to keep reoccurringly, at least annually, be doing an inspection of all your manholes to start, and also CCTVing. So the manholes, to reel it back in, is definitely a no-brainer. It's a very simple process to inspect the manholes as well.
I've got a variation on the theme question for you all. So I'm at Point of Woods, which is a beach community of about 425 homes, and we pump to East Lyme. And we pay for every gallon we pump. It's a brand new system, maybe 16, 17 years old at this point, and we watch our flows increase when it rains. And all of our pipe joints are still pretty good. Our suspicion is that most of that increase is sump pumps and downspouts. Wondering if either the panel or anybody out here has some thoughts of what you do to try to mitigate that or enforce. Most of you probably have regulations that prohibit sump pumps and downspouts from going in. Anybody have any good ideas on how they have been able to address that issue? And the group.
Anyone?
Well, in Litchfield, we do have a lot of property transfers. So, we just had a homeowner last week had a root blockage, and he just bought the house within like the last year. So we'll work with homeowners. Like, we don't want to come in with the stick. We want to be partners and encourage them that if they have concerns about their sewer connection, especially if it's an older house, because we have many homes in Litchfield that are over 100 years old and were connected to a collection system back in the 19th century, so they'll have vitrified clay pipe and cast iron pipe. So we've tried to do this approach where we're there as an advocate and not as a regulator, to try to encourage homeowners, even if they just have to do a spot repair. But again, we've done smoke testing in Litchfield, And of course, during storms, we go out and do visual inspections. But again, it's a multi-prong approach. I think that's especially a small community because you don't have, unlimited pockets to go after I&I. But, one thing we've suggested, which has been talked about in the industry is, at the point of transfer, just like if you had a house with a septic system, that you would say, we want your lateral inspected at the point of transfer. And then if there are problems, the seller can come off the asking price to repair it. So that's just a couple ideas that we've been trying to implement in Litchfield.
I'll add one other idea in the same vein as what Ted was talking about is we've recently talked with somebody who, if your sewer and water authorities are combined, if you're getting in to do a water meter check, there's just that extra reason to kind of get into the basement to check. Sump pumps especially is one that's hard to even find, because how do you get into somebody's basement to look for that? So the water meter inspection sometimes is a time to the access to the basement to at least look to understand whether you have those sump pumps or not.
Anyone out there? Okay.
Yeah, just one more thing. Another thing is curtain drains. Like with older homes, they typically have curtain drains, which, if it's in an area where it has a high water table, a tremendous amount of water, and that's a much more costly expense to force on a homeowner. So, you'll discover that, like, especially, going from the winter into spring, if there's curtain drains connected to your system and there's a lot of older house stock, that's going to produce a lot of flow that comes into the system.
All right, let's pivot to another topic around flow metering. And Ben, this would be for you. So what are some best practices you can recommend for flow metering and monitoring?
Yeah, so I guess kind of depends on what your objectives are, but it's definitely important to kind of lay out, basically, identifying locations with good hydraulic conditions. So we always say that kind of flow monitoring is much more of an art than a science. You're in this very kind of, challenging environment, to say the least, and the sensors are often in flow. And so if you're going through all the effort of actually installing meters, you want to make sure that the data that you're actually getting from that, is going to be valuable and as accurate as possible. If you're kind of, say, metering at somewhere with a 90-degree curve, right, you're going to have kind of different hydraulic conditions that might not be accurate. You're kind of looking at cross-sectional area and velocity in the water, and if it's too kind of turbulent, the data isn't really going to be accurate of the actual flow conditions. So kind of picking locations with good hydraulic conditions is really important. And again, if you're doing all of this, going through all this effort, you want to make sure that you're actually getting data that can drive these future decisions of, which pipes to line or where you need to add capacity. So.
Okay, yeah, and actually to that point, so if you're dealing with capacity challenges, how are locations for flow metering usually determined?
I think it can depend. So if there's a new development, oftentimes I think most of you here are probably familiar with, folks will be required to do some flow monitoring to ensure that there's capacity in the system for the new units. So at that point, you'd be monitoring the kind of area of the system where those new developments would be kind of going into. In other times, it really depends on the objectives. If you're looking at the entire system, you would break it up into kind of sewer sheds and for I&I studies, inflow and infiltration studies, we typically suggest, maybe 10,000 linear feet for basin sizes of pipe. And that just allows you to kind of understand which basins are, having the most RDII, the most kind of strongest rain-derived inflow and infiltration. So, again, it kind of depends on what exactly you're looking for. But yeah, hopefully that answered your question.
Anybody have any flow metering questions for Ben? Or an experience that you want to share as if you've deployed it? Yes, Ray?
For the operators out there, you should take this period of time right now, since we're in kind of a drought, that for the most part, your baseline flow is probably right now, or because I've talked to a few people and there was very little impact from our recent little nor'easter that we had because the ground is so dry. So your flows right now are pretty much going to be your baseline minimum flows.
Hold on a second. Oh,
There.
well, we did a lot of flow metering in Litchfield, and the most important first thing you have to do is, from an operation standpoint, is that when it's raining, you have to go pop manholes and see where the water's coming from, and then you can put together where you want to strategically place the area flow meters. And of course, you can't do it at this time of year, like Ray just pointed out, because you're not going to get much return on investment. I mean, it has to be during a wet period, which is typically the end of the winter into the spring. And then for a flow meter, it has to be in for at least 12 weeks. I mean, when we did it, we had them in up to 16 weeks in one location. If we found, like we use the term flashiness, if there's an area that's flashiness, we would move the meter upstream and start chasing and try to isolate where the majority of that inflow is coming from. And then, of course, when you get all this data, you got to put it into some sort of modeling software, which unfortunately we didn't do. It's still in my computer, but now it's kind of obsolete. But again, that's for the operators, like, my chairman used to say when it was raining, go out and pop manholes. And we did that for years. I'm like, we need to do flow monitoring. So eventually we did do that. But again, it's a multi-prong. Again, the operators know what's going on in the collection system, and when you want to make the investment, you want to get the best return on investment, because it is a service an engineering company's going to have to do it for you.
Thank you for saying that. Kind of talking about duration, right? You want to make sure to capture those significant rain events. And then also, oftentimes operators kind of know where the problem areas are when we're talking about I&I. And so, just in that conversation, it comes up, they say, oh, well, I know this section's bad, but, let's actually dig in and see, where that inflow and infiltration's coming from. It's kind of a collaborative effort for sure.
Kind of in the context of I&I strategies, Eric would be interested in having you talk a little bit about pressure sewers and the applications.
So some key advantages to pressure sewers is it's a sealed collection system, so it virtually eliminates I&I. So pressure sewers have been used a number of times in areas where the deep gravity system has such a problem with I&I. It's less expensive to replace the gravity sewer with a pressure sewer system using grinder pumps at the individual properties. So you can eliminate the I&I altogether.
Just for the attendees here, has anyone had experiences with pressure sewers or have any questions? Okay. All right.
I know in Vernon that we did a series of lakes called the Bolton Lakes, and it was all pressure sewered, and so far it's been working out fairly well.
Okay. All right, we'll go to a little bit about hydraulic modeling.
I can probably talk from this slide if we want. Yeah, this works.
Yeah.
So, I kind of introduced it before, and we were talking about flow monitoring, and one thing I'll slightly correct you a little bit of something you said earlier, Ted, is you said the flow monitoring data was kind of obsolete at this point, and it may be from an II tracking perspective, because things may have changed in 5 years. I don't remember how if you said how long ago. But that data can still be useful in terms of a hydraulic model, to at least have an understanding of what's going on in the system. So again, switching a little bit from the II, obviously reducing II you're getting flow out of the sewer, so it will actually provide capacity back. But if you're just looking from a standpoint of, hey, I've got some pipes, I've got some flow, but how full are these pipes? That flow data is still absolutely useful for it. It's a snapshot in time. You can figure out how much capacity was still available in those pipes at that moment. So I do this a lot for folks, especially when towns are having developers come in. You're talking about adding, a lot of people are doing those intense high density residential developments. We're bringing 100 apartment units into this area, and do you have can you serve that area? And so even a lot of people before didn't say we'd have hydraulic models, but I'm assuming most folks here have some sort of GIS system that at least shows you where your sewers are, gives you your size, has depth. With GIS, you can get length. You really already have the data available to set up even a very simple steady state hydraulic model. I've done Excel files of hydraulic modeling for small areas to get a sense of what's the capacity in this pipe. If I've got a flow meter data, even a little bit, if it's 5 years old, I've got a flow meter. Hey, I know there was roughly this much flow in this pipe. I've got some data in my GIS system. I can do a capacity. You can compare those two. You've got a snapshot. Now, as you get more data and as you get more great flow metering data, especially if you're doing every 10,000 linear feet for your basins, you can put this data into these more complex models and really understand when a rainstorm happens and the flow comes up, what does that do? The average day flow, your peak rain events. You can do a bunch of different scenarios in more complex models to understand, if I accept this new residential development, what's this going to do to me on that, that theoretical storm that's coming down the road? And there are definitely things can get more complex. As they get more complex, the data need is higher, and obviously the time to develop is higher.
I have one thing to add too. Just a suggestion for operators. If you should be monitoring your pump stations with some sort of SCADA so that you can collect data from your pump stations, and the data that you collect will be very telling. So during a storm event, for example, you'll see your run times go way up. Also monitor the watts and amps. So if you do a drawdown test at your pump stations, you can take the runtime and multiply it times the gallons per minute and come up with a pretty good gallons per day out of that pump station. So if you're trying to narrow down infiltration, you can isolate it to a particular lift station in your collection system and back into it from there. That portion of the gravity sewer system, you could start popping manholes and metering flow through the gravity system. I just wanted to add that in there.
Awesome. Because there were less folks that raised their hands around hydraulic modeling, kind of going back to just a basic question, and probably for multiple panel members, could you just articulate some of the advantages or the benefits of incorporating hydraulic modeling into better understanding or operations of wastewater facilities and collection systems?
Absolutely, and obviously there's different goals and there's different challenges that you might be trying to solve with hydraulic modeling. But to me, I think the biggest advantages are a couple things, right? We're talking about II locations of, where are these bottlenecks? Where are places, the problem children in your system? Where are those that you can kind of go target those types of things? When we start talking about at the plant, understanding when these spikes are happening, how quick they happen. And then obviously, as we talked about with the, capacity analysis when the developers come in, those are the big advantages of that in terms of understanding what, we have a lot of pipe buried in the ground. We don't always know everything about those pipes. So the more you understand it, it makes everything easier when the unknown comes up or the big developer shows up or the II study happens, or all of a sudden you see a new spike of flow at your plant. To be able to, you've got the baseline of information created, so when things change, you have something to start working from to do that hunting to find out what the new piece of information is. But obviously, there's so many parts of an operating of a sewer system that go into things that the target, like we said before, with the flow metering is understanding what that goal is. Like, what's that question you have to ask? Is it a question about reserving capacity for development? Is it a question about treatment plant capacity? Is it a question about a pump station that is having issues or capacity problems at a pump station? Understanding what that goal is, having that piece of information to start solving that concern is a huge benefit of hydraulic modeling.
Any other insights from the panel? Ted?
Well, our commission, they just updated our rules and regulation. I mean, obviously Litchfield is a small rural community that serves about 3,000 residents, but we had to update the rules and regulations to put in the structure of what he was just describing, that if a developer comes to you, you know, it's just not a conversation, that there's a process that a developer, whether it's commercial or residential, actually goes through, so that there's like, you know, they know exactly what they have to do. The onus is put on them to do their due diligence. The WPCA can review it with the plant superintendent or the public works director. And so that was a big change for us that we just implemented in July. And so for as long as I've been at the plant, it was more about a conversation and just collecting the connection fee. There wasn't any sort of discussion about, are we surcharging this line? You know, how many connections can we take? But now it's much more structured for us, so that should be beneficial for our users and eventually save us money.
You've opened up the topic around, you know, sewer connection applications and structure. So, James, I'll put this to you. What have you seen with your clients as some of the common items that are missed in like a sewer availability request?
Thanks, Kat. So I think just to start off broad, the sewer availability process, when you're looking at, you know, allowing these connections in, all the stuff we're talking about, the hydraulic modeling, the flow metering, you know, reducing I&I really ties into that directly, because you want to be able to have in most cases you want to be able to have capacity for these developments, you know, to be able to connect and develop and prosper in the municipalities. So going into, you know, key items that are often overlooked or missed, one would be, are they actually connecting to, is the sewer they have identified actually a public sewer? You know, there's certain situations where you have a subdivision or, you know, a big mall, for example, where there might be private sewers on property, and it might be the closest one to this new development, and they're like, oh, I'm going to connect here. So that's definitely something to look for, and the municipality or the water pollution, you know, authority should be able to help guide them towards that. Another thing that's often overlooked is, you know, when you're looking at flow allocation, people often look at average daily flow, but there's a peak from the development too, and especially if there's an on-site pump station to be able to get it up to a gravity sewer, or a similar situation where now you've got your pump flow rate actually supersedes the average daily flow rate if you were going to create that hydraulic model and put it in there to accurately reflect. Downstream pump stations as well are sometimes overlooked. You might have a gravity sewer that's got millions of gallons of capacity and it looks great on paper, but it's going to a pump station that's already exceeding or right on the edge of its capacity, or needs life. And then one last key factor that's, you know, the model will tell you a lot of information. If you've got all that data, it's great. But the operations and maintenance knowledge of the staff is really essential, because there's so many factors in a sewer system. Like everyone here said, it's underground. You don't always know what you're dealing with. That may not be directly related to capacity, but you know, there could be root or capacity that you would see through modeling or flow metering. There could be root intrusion. An area with a bunch of restaurants could be backed up with grease constantly. So even if on paper or, you know, the Excel spreadsheet or even an advanced model says, hey, everything's good, we got plenty of capacity, if it hits an area that's obstructed or has other maintenance issues, it could present a problem down the line. So that operation knowledge from the staff and the operators is really essential part of the process. And unfortunately, in some cases, they don't always get the opportunity to get involved until kind of the tail end. Because oftentimes it'll go to a planning or zoning review, then it might get passed to an engineering or a third-party engineer or DPW, and then by the time it makes its way to the sewer connection part, you know, so much money's been spent on this development that people are trying to, you know, push it forward, and it, you know, so getting involved or trying to communicate to get involved as early as possible helps avoid some of these missteps and smooth the process along. So, if there's any questions on that.
Go ahead.
What kind of safety factor do you guys plan for, you know, when you're looking at developments moving at like 80%, 95% of the pipe capacity?
So you're talking like flow, safety, yeah, so it really varies. If you have really good data and you have flow monitoring or flow metering that's relatively recent, and you got a hydraulic model, you might be comfortable saying, oh, I'll run that pipe at 80%. You know, I think 80% is a lot of times the max people like to go. It's a little bit high because then you're really right in that line. Laterals are coming in, unless they're all drop connections or deep connections. You don't want to be backing up people's basements or homes. So that's definitely a factor. If you don't have any data, and you're just looking at a pipe, you know, say, especially smaller pipes, there's really two ways, you know, two categories you could look at. Smaller pipes, you know, 8 to 12 inch. If something's coming in and it's taking up even 20% of that line, and there's other stuff that's connected in it or unknown, that might be a red flag for some people. And it's a level of familiarity with the system, how big the system is. If there's not a lot of stuff upstream, you may be able to say, oh, okay, I'm okay with a higher number. When you get to trunk sewers, you know, 36, 48 higher, you know, even 60-inch sewers, you may back off that number and say, okay, well, that, you know, this is really a conveyance to get it from A to B. And we can run that trunk sewer a lot higher without operational issues that you would see in a local lateral sewer or collector sewer. So there's factors that go into it, but yeah, I would say the 80% number would be kind of the high upper limit of what most municipalities, I would imagine, be comfortable with.
Back there.
Good morning. I just kind of, you know, we talked about flow metering, you talked about hydraulic modeling. I kind of want to go back to point A. You have a new development that's proposed to be constructed. I'll give you an example. Say it's a 100-unit residential community. How and what is your approach to determining what the quantity of flow that development is going to contribute to your system to further help with your hydraulic modeling?
So when calculating the flow, there's often guidelines and standards that are standard, and I believe for Connecticut, it's the Department of Public Health has flow standards that'll be allocated per unit. So if it's 100 residential units, like you said, there'll be X gallons per day per unit. And then varying different types of commercial, institutional, you'll have office space, medical office space, often assigned per square footage. So that gives you a roundabout baseline, and that's often what, you know, Department of Health and other boards are looking to have. That's the basis. Oftentimes you can't just come up with your own number. You know, you have to use those standards at least as the, you know, the first factor. The things that start to vary a little bit are sometimes process or industrial uses. You can have a food manufacturer that, you know, maybe produces prepackaged meals and uses a ton of water. Stuff like that, you would need additional input from the occupant that's going to be working that, the process, what exactly their process, what their water use is. So, and you can also look at similar applications, you know, in the residential. Sometimes the regulatory numbers from the Department of Public Health, those can be higher than what you see in real life, but that's also just another factor of safety on top of that. And from there, you know, the point I made earlier about peak flow, you often want to look at what, you know, the peak, and there's industry standards for peaking it as well, you know, from anywhere to, you know, roughly 2 times to 4 times average daily flow is common depending on the size of the development. So that's really the number. Even if you're not governing with that, that should be looked at in the model if you have one, to say, if everyone wakes up and takes their shower at 6 a.m., what's my sewer going to look like? You know, not at 4 a.m. in the morning when everyone's sleeping.
Do we have more questions? Go ahead.
Real quick, I just want to say in Fairfield, we invested in a smart cover, which is an absolute fantastic tool for flow monitoring, and it's mobile. I can pick it up and send it to this manhole, 100-foot distance, a mile, doesn't matter. We have data forever now. We can put it where we want it. It was prior to our I&I, our sealing program with National. It is critical, and I recommend it to any community, any plant that can afford it, get it. You have flow data at your disposal. It is a fantastic tool, and it's been super beneficial to us in Fairfield. So just wanted to make
Don't
that
go
clear.
away. How much does it cost? I think people would be curious.
I'm going to take the fifth on that. Very expensive, but it's worth it. In the long run, let's look in the long run, you know, you make a $150,000 investment. The millions we're going to save over the course of even just a decade, it's going to be well worth it. It's well worth the investment that we put into it, especially for being able to really focus on I&I points, our road crew. They know, and you were saying something about experience. It's important our operators have that experience. These guys are like, yeah, I know you want to see what the flow is up here, but I'm on the road every day, and I know this is the area we need to focus on, so we can set those smart covers up right where we want them. So the investment, we're looking way into the future. So I can't really answer that. I think we have 12 units.
Okay.
I don't know the answer, but
That's
there you go.
Okay. In the back, towards the back.
Yeah, thank you. Good morning, everybody. My name is Carlos Esguerra, and I work with Connecticut Deep Municipal Wastewater. And I just want to take this conversation a little bit to a beginning. I think everything that is being said during this discussion is great. But when looking at accommodating economic growth or growth within the sewer system, you're also going to be looking at your permit and make sure that the additional flow is not going to cause your flows to exceed the capacity of your treatment plant, right? We've encountered issues where, you know, towns want to promote economic growth, extend sewers, but the average flows at the treatment plant are almost reaching or exceeding the design flow rate of the treatment plant. So I think that's one of the first boxes that you guys got to check, is make sure your permit can accommodate the sewer, right? That's one of the first things. The second thing is, we've also encountered like a disconnect between WPCAs and planning and zoning. A lot of times the two boards don't talk to each other. So make sure that, you know, your input is taken by the planning and zoning officers and city council, town council. There is a document every town should have, which is a plan of conservation and development, the POCD, and that POCD dictates kind of like how the town is going to go about extending sewers or not extending sewers to some areas. So those are a couple of key points that I wanted to convey in this conversation, like the very basic and I&I removal, and I think we can all agree that sewer capacity is an asset, and unfortunately when we don't have it, we're kind of like scrambling at the last minute trying to create that capacity, and this is where I think I&I and hydraulic modeling comes into play. But I wanted to go back to the very basic conversation, which is, you know, making sure we check those first boxes first.
And if I could just add, Carlos, I mean, most of our NIPD permits have the 90% of design flow as the criteria for, you know, if you hit that number for 90 consecutive days, you know, then all of a sudden you need to do an engineering study. So, you know, that's the other thing that, you know, sometimes when we go into wet periods, like, you know, you might be doing 85% of your design capacity and you're not really worried about it, but if you go over that threshold of 90%, and for us in Litchfield, that's 720,000 gallons a day. You know, I did it for 2 months a few years ago, so I was kind of like just watching the weather and saying, is this going to keep going?
We have some towns that have moratoriums right now that don't allow any connections for that reason. So I also wanted to put this out there as well.
The one other thing, am I on? All right. The one other thing I was going to put up to this was, the plan of conservation and development map. If the developer's coming in an area that's already been defined as a sewer avoidance area, and they want a sewer connection, that's one of those early checkboxes that Carlos just mentioned. And the other thing that we were talking about when Ray's question about how to define those flows, kind of marrying on to something you said earlier, is that's something that I would, if you have, where you're creating this standard process where it's not just a conversation, we have rigid, I would put right in there, these are the flows we are going to use. We are going to base it off of DPH's rules. Or I have a client who's had a developer come in and said, hey, we've done this massive flow study. This is the flow we're actually using. And they've decided to adopt that as their new, but as long as you set that kind of in a policy somewhere, you've got a standard way of this is how we're evaluating them, then it's fair for everyone. Where you can get yourself in a little bit of trouble is when you use one use flow for this guy and then another flow for this guy over here, unless you've got a basis for it. You've got to be, you want to have a standard way of doing it. That's going to be the best way. You can do it the same way every time, and it's fair and kind of equitable for everybody.
That's great. I do have one more question, actually, for Carlos. If you are finding that, let's just say the flow is increasing, not due to I&I, but really substantial growth, maybe converting some commercial building that's been empty forever into residential, how hard and what is kind of the time frame if a municipality wants to increase their permit limit for discharge with their NIPD's permit?
There is a condition in the permit that requires when, kind of like what Ted was talking about,
Yep.
when the average flow reaches 90% for 180 days, the town has to do some engineering report, right?
Okay.
So a couple of ways they can do I&I, but I&I takes years, right? You're not gonna see the results from I&I overnight. Or the other option is looking at the POTW and seeing if you can increase the capacity of the treatment plant, but maybe looking at some IFAS or something, I don't know. But that's not gonna happen overnight.
Yep, okay.
Yep.
Good. Thank you. I think quite a bit of what we've talked about does require investment and funds. And so I want to give a little airtime to Martin Heft, who is with Office of Policy and Management, who can talk a bit about what funds are available. We're familiar with the Clean Water Fund, state revolving funds. He's just one more little trick in your toolkit for money.
Good morning and thank you. And you're probably wondering, what does OPM know about sewers, right? My past life, I was actually a municipal official and chair of the WPCA for 12 years. So I do have an understanding about water pollution control and a forced water, a forced sewer main, and combining into another sewer system and everything. So I do have some background in it, but I'm not an expert at all, so I'm learning a lot today as well. With that, I did want to just offer, with the Connecticut Office of Policy and Management, we offer a couple of grant programs that could be applicable for infrastructure for sewers. There are a number of opportunities out there through the state besides whether you go to State Bond Commission, the municipality, and get something through what we call the Urban Act. There's also the Clean Water Fund. One thing I will just caveat everything as the bottom line there says is that every program has its own specifications, its own application process, and its own, priorities for what those are. So you definitely want to, look at those to see which is the most relevant and which is going to be the most helpful depending upon the type of project that you are doing. My division, the Intergovernmental Division at OPM, we actually administer two types of programs. I'm going to speak mainly on one, but I will mention there is a program called the Regional Performance Incentive Program, or called RPIP. It's offered through your local Council of Governments, your COGS, which the municipalities can go to. Basically, it's a shared regional services type grant. So it's not as much as the infrastructure part of, building the sewer and everything else, but if there's shared services that can come out of that, you're sharing it amongst multiple towns and everything else, there could be some potential there. So just another opportunity to look into that program. The program I'm going to talk about today, though, is a Small Town Economic Assistance Program, commonly known as STEEP. This is basically, it's a state statutory program. Was originally, I mentioned the Urban Act. There's a number of towns that, or cities that get Urban Act, but they're not eligible for STEEP for that. So there was a program developed for smaller towns to be able to apply. Each time we run a grant round, there are different qualifications and different amounts. The good news is the legislature 2 sessions ago actually finally increased since this was done. It used to be a cap of $500,000 for STEEP for any municipality to receive in a fiscal year. They increased it to $1 million for that. One of the caveats we have in there is one of the program guidelines is that we request a 20% municipal match. That has to be municipal dollars, can't be other grant funds and everything, because there should be the municipality teeth in the game, if you will, for that. There is not a set STEEP grant round process as some other grants are. It's on when funds are available. We've run most recently 2020, 2022, 23, and we just closed out 2025 with about $30 million that we just did. So not foreseeing that there's going to be one this fiscal year, but I can tell you that there in the bond bill that was just recently passed, they did put money in fiscal 27, so that's an indication of when a future round might be coming. So I won't go through all of the things, but these are the eligible and priority projects. This is all up on our website under, STEEP and everything. But what I want to, highlight are a couple of them that are on here as eligible projects. Solid waste disposal projects listed down about the third bullet down. And then if you go second bullet up from the bottom, development projects including economic community development, transportation, environmental protection, public safety for that. And then additionally, this administration has picked some priority project areas that when we go through and rate the applications, these are some of the things we look at. Obviously, one of the top ones are shovel-ready projects, where they're at a stage to begin work. We're not looking at funding studies. We want, shovels in the ground ready to go if we're going to put money out and capital funds out from the state. And then obviously on the bottom there, you also see pollution control, water, waste, energy in order to reduce costs and environmental impact. So those are, for this administration, priority project areas. So if you have projects, as we're sitting here talking about today, those are some of them. Since 2005, going back through, STEEP has funded about 27 projects, almost about $8 million. For that, various ranges, from, connection of a dog pound, which was, they only asked for $5,000 at that time, to a municipal sewer system, to those caps of $500,000 at that time for that. So, there are programs out there, there is funding available, so, work through the municipalities. Those are the only ones who are eligible to apply. Their eligibility lists and everything, they get notified when those applications are, being accepted.
Hi, Martin. Define small town.
Well, it depends. There's all kinds of definitions. It's interesting.
What is the population criteria to be eligible for STEEP?
It's actually for STEEP, okay, and this is why I go back to every program has their own, definitions. Every program has their own qualifications. For STEEP, we use a thing called the PIC index. For that, and basically, there's, if they're a distressed municipality, if they have a, kind of a business center, which is in the state plan of conservation and development, there's different criteria on here, and, if they meet those certain criteria, that's how they become eligible. We actually have an eligibility list on our website for STEEP that shows which municipality, so it's not based on population at all. It's based upon, it's a public investment community is what a PIC index is, and that's used for a number of grants. So I, urge you to take a look at that listing on it because it's not a population-based grant. Thank you.
Has anyone utilized a STEEP grant before? No. Okay. Well, it's another tool for you all. Martin had mentioned shared services agreement, and while we're talking about funding, I think he also mentioned the regional councils of government. They do have grants available, and they're definitely promoting where municipalities can get into shared services agreements, whether it's, pairing two towns and one has an under capacity waste treatment facility, and the other town is kind of bursting at the seams. There is definitely funding, so look for the cog that you're in and make sure you have somebody in your municipality tied into the executive director for each cog. Each cog has a newsletter that goes out monthly, and they often list the grants that are coming available. So it's a great resource, and it doesn't matter the size of the town. It just depends on what council of government region you're in. So that's a good resource to look into. I do want to give a little airtime also to Norb Church, who has done quite a bit of work dealing with moratoriums, intermunicipal sewer agreements. And, I would love to hear a little bit about, something messy, something tricky, pointers for, entering into intermunicipal agreements.
So my experience has been with very small communities. I've done a lot of sewer and water work for the town of Brantford, a big sewer project for North Brantford. And also just recently a water project for the town of Guilford. And interestingly, the statutes for water projects and sewer projects kind of mirror each other. And most of what I've been involved in is either extending water mains or extending sewer service. So Point of Woods that I mentioned earlier is a small beach community of 425 homes, and and they were facing constant beach closures due to high bacteria levels. And regrettably, at the time, the town of Old Lyme did not want the idea of sewers in town, and yet there was an issue that needed to be addressed. And what ended up happening was Point of Woods, like a lot of beach communities, is its own municipality, their own tax district. And Point of Woods was able to work with the folks at State Deep, and we made it happen. And we entered into an agreement with the town of East Lyme, where we pump to, and essentially we pay for everything till we reach East Lyme. They charge us by the gallon for what we pump to them, and our rates are based on, essentially they treat us as if we were an industrial user, so by way of their own regulations. So we pay kind of at an industrial rate to the town of East Lyme. Right now I'm working on representing Old Lyme Shores, and there are 4 beach communities now in Old Lyme that are been working for years and years and years and years and years to try to put together a plan which I think is coming very close to fruition of these 4 beach communities would also pump to East Lyme. I will say that the folks at Deep on both projects are just amazing. They totally think out of the box, Carlos and your gang, with how creative they are in funding and making projects happen. And obviously, one of our concerns is actually limiting rather than expanding. So in the sense of when Point of Woods was put together, the pipe size going to East Lyme was just large enough to accommodate us with a little bit of, just a little bit of buffer. So there was no opportunity for others to be able to join in. Now, maybe that was a good thing, maybe that was a bad thing in retrospect. Deep and the town of East Lyme were very concerned about restricting the amount of flow because we are on sort of borrowed flow, if you will, from the state of Connecticut for Point of Woods. The other 4 beach communities will be pumping into a force main out onto Route 156 that will also run parallel to the Point of Woods main. And again, that pipe is going to be limited in size so that there's a little bit of buffer for a little bit of development, but there's not an opportunity for industrial users or anyone else to join in. So, you know, we're kind of looking at it from the get-go situation as opposed to the repair situation, and purposely designing pump stations and pipes and all so that there's just no opportunity to, beyond the buffer, to expand any flow. So that's kind of my perspective from a small community vantage point, and most of my perspective has been in building extensions, which, by the way, whether it's water or sewer extensions, keep in mind one of the ways that you can finance these projects is through assessments. So any of the projects that I've been involved in, whether it's a water assessment for Guilford or upcoming sewer assessments for the beach communities, the homeowners ultimately will be paying for most of the construction, much of it coming by way of loans and grants either through DEEP or the Department of Health. It's essentially 20 years at 2% interest that we pay back the state, and then that's simply charged back to the homeowners by way of assessments. The assessment at Point of Woods was about $22,000, payable over 20 years, so it's about $1,000 a year is what those homeowners face. The good thing for them is that it stopped the beach closures, the high bacteria counts. At the same time, with the Department of Health, we're able to put in permanent water. And so what we're able to do was eliminate leaky septic systems. We're able to eliminate wells. And whether you do one project or the other, for instance, in Guilford, bringing in city water by way of the Connecticut Water Company meant that everyone could abandon their wells, which then gave you a much larger radius distance for septic system repairs. So we're trying to hold off, ever having to have sewers in those areas by having properties have enough room for being able to place septic systems or repair their septic systems. I've said too much. Thank you.
By a show of hands, is any municipality involved in a intermunicipal sewer agreement? I'd be interested in hearing like how, if anyone has a perspective or story they would be willing to share. And you don't have to tell us which municipality you're from.
Well, Kat, I'll just add, and, had some conversation with some of my peers. A lot of these IMAs are open-ended. Like I have one, our major IMA, was drafted when the plant was built back in the 1970s. So, that community doesn't have incentive to change the IMA. But again, over the course of the decades, their inflow and infiltration has, impacted our plant. So, our commission, I just emailed them a couple of the older versions so that they could look at them. And, we recently renegotiated one with a larger municipality, and we felt it was a good agreement on both sides. But again, it's a legal document. It's a contract between, two different communities. For us in Litchfield, I have 3 IMAs for a small community. So, again, it's another component of dealing with I&I because it could be coming from another community, and they may just want to pay you if you surcharge them because it's cheaper for them to do that than to borrow money and fix their collection system.
Yep. All right, we're pretty much at time. I don't know if anyone has a question they've been wanting to ask but didn't have the chance. Go ahead.
This is, I want to get a much broader question for the panel. We talked about flow monitoring and hydraulic monitoring, all components of an SSES. What would be your methodology or approach to a community who is looking to undertake an SSES or a sanitary sewer evaluation survey? What would be your recommendations on how they should approach it, what steps they should take, and what should be included, in that study? And then to follow that up, when the study's all said and done, how do you evaluate the cost-benefit analysis of treatment versus rehabilitation?
Yeah, I guess I can speak to at least the beginning of that, right? Because I think this does begin with flow monitoring. So again, kind of either working with some engineering consultants, working directly with a flow monitoring provider like ADS. You basically kind of dividing the sewer shed up into subbasins and figuring out when you're able to do that springtime monitoring. Then it comes to evaluating that data. I think some other folks on the panel here can talk more about kind of what you're doing after, right? But I think the first part, this obviously isn't cheap, right? The entire process, and so flow monitoring, I think, is an important part to understanding, basically, to prioritizing these investments later on down the line in that SSES work. So I don't know if, yeah, here we go, Travis.
Yeah, I do. Thank you. Kat, can you pull up my case study slide, please?
Yes. Good.
Thank you. Can I come up there?
Yes, please.
Thank you. Yeah, absolutely. So to touch on what you were asking about, hey, what are the first steps and what are some of the cost savings, right? So if you guys take a look up here, can everybody see this all right? Cool. Love your guys' feedback. Appreciate it. So if you look at this is just a really simple 5 gallons a minute I&I leak here into a manhole. So you can see this is from this year. This is an average cost that we took from local municipalities around the state. You can see what it costs here, per minute, per hour, per day, per month, per year, and what the cost is per year, right, from a 5 gallon a minute leak, over 2.5 million gallons per year of I&I, and that's costing you just over $7,000 to treat at the rate of your cost to treat your wastewater. Does that make sense? Yeah. So with that being said, the average cost of a company like ours is about $3,000 to stop that leak. So you're getting a return on investment, in half a year, 5 months, so 138% ROI. And you're saving $7,000 a year after that on a very small leak like that. The power I want to give this is if you take a job we just did, we stopped a leak of 200 gallons a minute in a sewer system. So if somebody can do, right, if you go from 5 gallons a minute, $7,000 a year, that's a 40 times increase. So if somebody can pull out their calculator and do $7,000 a year times 40, and tell me what that dollar amount is, please. How much? Right, so could we all agree that $280,000 is a significant savings? Right, would anybody want to not spend 280 grand if you just simply didn't know about the leak and get that money back, and we could all agree we could put that money towards something else? Right, so fix your I&I. Yeah, so I just wanted to use that, and I hope that speaks to what you were asking and the power and how much it can very quickly compound with one large leak or multiple small leaks, you know, and just starting, you know, at the top of the ground. You know, right over here, it catches my eye, you know, we got some composite manhole risers here. You get these things, you bolt them together, seal them up, start right at the surface level, keep this I&I right at the top from getting into the sewer system. You got roads that flood and things like that. You can replace these old, you know, steel frames and covers that, right, they're steel. And what do we put down on the roads in the wintertime that deteriorates them very quickly? Doesn't deteriorate stuff like that. So we get the manhole lid sealed, we go in there, get the manhole sealed, pipe penetration, pipes, lateral lines, and just help, you know, mitigate reduced I&I, and you're gonna be able to see black and white your guys' savings. And I know they got the cookies out, so I'll stop talking. Thank you.
Go ahead. I know there was a couple parts to his question, so.
Exactly. I was going to try to talk to one of the other parts of Ray's question. And to me, one of the things, you know, internally when we're, as an engineer, right, we're helping scope out a lot of these SSCS kinds of studies and how you do things. The one thing I always say internally and also to clients is the idea of keeping that goal in mind. When you enter into that SSCS, when you're trying to find that II reduction, you know, keeping that goal in mind, what started you on that process? If you're trying to engage an engineer to do SSCS, you have a problem, you've identified, you know what it is. Always make sure we keep that in mind, because that's always going to guide the scope of what you want to do and how you want to attack it, how hard you need to attack it, how long you have to approach it, all of these things, whether you phase it and you try to do a bunch 1 year, phase it over 10 years, whether you're trying to look for inflow and you're trying to do more something, either a smoke testing or a manhole inspect, or you're trying to find those, the baseline of your flow keeps creeping up. So that's probably those everyday leaks. That's probably more, could still be manholes, but maybe more pipes and things like that. So I always advocate keeping an eye on that goal of what sets you on that process of needing to do an SSCS, needing to, you know, what's making you have to go find those leaks? Is it, you know, is it the peak? Is it the baseline? Is it specifically a cost thing? The plant's running fine, it just costs too much. You know, keeping that goal in mind, and that's gonna be slightly different for every system, but keep that goal in mind as you both scope it out and then continue through the work. And actually, the other part of it is towards the end, once you've done some II work, keeping an eye on those flows, whether it's plant, whether it's more flow metering, whether it's pump station flows that we've talked about, using some way to kind of keep a post-monitoring, you know, post-rehab monitoring plan, so you can actually kind of prove out. So when somebody says, hey, we just spent, you know, I don't know how much, you know, we spent a bunch of money fixing the lining your pipes. Well, how much money did you save? If you can prove that after the fact, it makes things so much easier when you have to go back to a board for the next round of funding, or a town council or something like that, to say, why are you spending all this money? Or why, you know, why is our debt service so high? Those types of questions, to have that basis of it, it shows you right where, you know, yes, this is the savings for it. You can prove those numbers that we just talked about. So keeping that goal in mind is always a priority when these types of things come up.
Right. I know we're over time. I appreciate the panelists and your patience as we kind of warmed into this, and appreciate the questions and attention from all of you. Thanks so much.